Hi everyone, so I'm going to do the review sheet for your first test of the second quarter. The first question says the solution to the equation 18x squared minus 24x plus 87 is. Now looking at this, I know I'm going to have the quadratic formula in my work because if you look at the choices, this has plus and minus, has a radical, and that looks exactly like the quadratic formula. So what I'm going to do is I'm going to plug in a, b, and c into my quadratic formula. So if I look at this, I have a is 18, b is negative 24, and c is 87. When I plug this in, I have x equals negative 24 plus or minus the square root of negative 24 squared minus 4. A is 18 and c is 87 all over 2 times 18. Now simplifying this, I get x equals positive 24 because it's a plus and minus makes a positive, plus or minus the square root of negative 5,688 over 36. Now if you look at that, that's a massive number, 5688. But if you look at the choices, every single radical has 158 in it. So what I did was I divided 158 and 15688. And what I end up getting is negative 36 and 158. So that helps me because 36 is a perfect square, and I know that this reduces to 6i, I because of the negative. So doing this, I'm going to have 24 plus or minus 6i radical 158 over 36. Now I can cross off two choices, and the two choices I can cross off right away are these guys, because you notice how they have negative 2/3. That can't happen because 24 is positive. So these guys go away. But I'm still stuck with those two. So if I do this, I'm going to do my heart here. And I'm going to get 24 over 36 plus or minus 6i over 36 radical 158. This reduces to that 2/3, the 24 over 36. If you're not sure, you can just type it in your calculator and you'll get that. And then 6 over 36, that's 1/6, and there's an I in your 158. So your choice for this will match choice 4. So for this question, you have to factor because they want you to set CM equal to 0. So all I'm going to do is replace that with a 0. And looking at it, what I'm going to try to do is factor to find my solutions. And because it's a 4-term thing, I'm going to be able to factor by grouping. My GCF here is m squared. I'll be left with m minus 2. And because I want m minus 2 on the other side, I'm going to pull out a 4. And then I will write m squared plus 4, because that's what's outside. And then m minus 2 once, because these guys come together. And then what we're going to do, since we set the whole equation equal to 0, is we're going to solve, add 2 over, m equals 2, equals 0, subtract 4 over, negative 4 equals m squared, and I'm going to square root this, m equals plus or minus 2i. Square root of 4 is 2, square root of a negative is I, and I took a square root, so I get plus or minus in front. And then I get my answer choice of choice 4. This question is a square root equation, so remember the first thing you want to do is subtract the 2, isolate the radical. So I'll get negative x minus 2, and then I can now square both sides to get rid of the square root. And I get x plus 4 equals negative x minus 2 times negative x minus 2. And on a box method, the right side, negative x minus 2, negative x minus 2, and I'll get x squared plus 2x plus 4. And I'll have x plus 4 from this side equals x squared plus 4x plus 4. And then I'm going to set this equal to 0, because just like the previous problem, you want to be able to factor it. So doing that gets me 0 equals x squared plus 3x. These cancel. And I'm going to use GCF again So plot an x and an x plus 3. And what I'm going to do is I'm going to set these both equal to 0 and subtract the 3, and I'll get x equals negative 3 and x equals 0. Now make sure you check your answer, because when you do, either by plugging into the original or using the y equals trick, you're going to reject x equals 0. It's an extraneous solution, and x equals negative 3 is an answer. The next question says, for the polynomial, list each real zero and its multiplicity and to determine whether the graph crosses or touches the x-axis at each x-intercept. So let's figure out the zeros. So I'm going to rewrite this. When you're trying to figure out the zeros, you're setting your equation equal to 0, and you're breaking each piece up equal to 0. So 5 equals 0. Well, that can't happen. What the 5 is actually just creating a vertical stretch on the graph. So 5 is just changing the shape. It's not a 0 at all because of this little fact here. That can't ever happen. With these two, though, we're going to set them both equal to 0, ignoring the exponents. So I have x equals negative 1, and those exponents are your multiplicities. This is a multiplicity of 3. Remember, multiplicity is how often that answer occurs. So what literally you would be able to expand this piece, x plus 1, 3 times, getting 3x equals negative 1. So that's why we say multiplicity of 3. And then for this piece, I'm going to set x minus 3 equal to 0, add the 3, and I'll get x equals 3, positive 3. And that tells me my multiplicity is 4 because I have an exponent of 4. So looking at my choices, I can cross off choices 1 and 2 because we already decided that they do not, there's no 5 in your answer. It does not exist. You can't have 5 equals 0. Now I'm down to negative 1 multiplicity of 3, crossing or touching. So the only difference between these two is if it crosses or touches. Now if you remember, I told you even, touches, odd, crosses. What I'm talking about is the multiplicity. So this is an even multiplicity, so it's going to touch at 3, and this is an odd multiplicity, so it's going to cross. We're talking about the multiplicities again. So I'm going to have choice 3 because it's an odd multiplicity, which means I cross, and the 3 has an even multiplicity, which means I touch. All right, so this question says a fourth degree polynomial has the zeros negative 5, 3i, and negative I. Now, because negative 5 and 3 are our answers, I know I need to cross at negative 5 and 3. So I can cross off these two guys because they don't even cross at negative 5 and 3. And then I'm going to cross off choice 1 because my other two answers are imaginary, which you will not see on the x-intercepts. I know there are 4 solutions, but because these two are imaginary, we do not want 4 x-intercepts like the one in choice 1. So I'm going to pick choice 2. This question says, write the polynomial p with the lowest degree possible that has these solutions. Now I told you guys to cross off the first I because I didn't want to make it too big. But the first thing you're going to do is set them all equal to x, and then you should know from the conjugate pairs theorem that if you have 2i, you have negative 2i. And then you're going to bring the numbers back to the x's by changing their signs. And then you're going to box method this. I would box method the i's first because they're partners and they probably will work out nicely. So I get x squared minus 2xi, and then plus 2xi, and then minus 4i squared, which allow these to cancel out. You'll get x squared plus 4. The reason why I get plus 4 is because I squared, remember, is negative 1, and that'll reduce to 4. Then bring down the x minus 3. And then what I'm going to do again is box method. I'll get x squared and 4, x minus 3, x cubed 4x, negative 3x squared, and negative 12. And this will get my polynomial p. So I'm going to name it p of x. Please don't forget to name it x cubed in decreasing power order because that's called standard form. And boom. Now if you wanted to check, you can put this into y equals and then look at x equals 3. If you see 3 has 0 as the y value, you did it right. This one says, what's the equation of the directrix? Now, what they're talking about, remember, is that a parabola has a vertex, which is here, a focus, which is inside of it, and a directrix, which is the line underneath. So they want you to find this guy, the line. So the first thing I'm going to do is find my vertex from my equation. Now remember, you want x comma y. So look at the equation very carefully. x is 3 and y is -1. But remember, you want to change the sign, so it's going to be -3, 1. So the first thing I'm going to do is I'm going to plot -3, 1 on a grid. Remember, you can use scrap paper for this. This is my vertex. Now what I need to be conscious of is if this opens up, down, left, or right. Now because x is squared, that means left or right. And because the 20 in the front is negative, I'm going to pick, oops, that was silly. Because x is squared, it's up or down, I'm sorry. And because the negative is in front of the 20, we're going to pick down. So I'm going to go down. And then this -20 is actually really important because if you remember, the actual equation is this. It's -4a because we have -4a because the 20 is negative. This here matches up with the -20. If you set it equal to -20, what you're going to be able to find is that thing called the a value. What the a value does is it tells you how far the directrix in focus is from the vertex, and it's 5. So what I'm going to do is I'm going to count 1, 2, 3, 4, 5, and that's where my directrix is. So my equation, my directrix is y equals 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, yep. If you wanted to find the focus just for fun, you would go 1 down from the vertex, so 1, 2, 3, 4, 5, 1. So let's check 1, 2, 3, 4, 5. So it would be down here at -3, -3. Because that's 1, 2, 3, 4. Actually, one more, 5. -3, -4. All right, so this question says, sketch a polynomial for the possible function p of x, where a, b, and c are positive, a is less than b, and p has a negative y-intercept d, and label all the intercepts. Make sure you don't forget that. Now, first thing I'd do is label my negative y-intercept d. That's easy to label. Now, technically what's happening here is you would set these all equal to 0 to find your x-intercepts. You get x equals -a, x equals -b, and x equals c. Now, it makes sense that c would be here because it's positive, and then we know that there are 2 x-intercepts over here because they're both negative for these guys. Now, the only thing that is confusing about this problem is a is less than b. So, that is when a, b, and c are positive inside of the equation. So let's play a game. We're going to make x plus 1 and x plus 2 and x plus 3. I picked, x minus 3. What I'm doing is I'm putting numbers in for a, b, and c. Now, when they say a is less than b, so that's why I did that. And I'm going to set these all equal to 0. I get x equals -2, which means the negative b. X equals 3, which was the c. And x equals negative that was weird. X equals -1, which was negative a. So what I'm going to do is I realize, well, negative a should be here now, and negative b should be here now because -1 is here and -2 is here. Okay, but I don't want to label it that way because they want us to use the letters. So now all I have to do is connect. I need to go through this guy, I need to go through him, and I need to go through these guys. And that's my polynomial p of x with all my intercepts labeled. This next question says, algebraically determine if the functions are even, odd, or neither. To algebraically determine if a function is even, odd, or neither, you plug in -x wherever you see an x. So I'm going to do negative x squared minus 4. Now this negative will stay outside, and this negative cancels out because it's a negative times a negative. It's squared, so there's 2 of them, and ultimately it just becomes x squared. Now looking at this matches that, and it matches that. So because they match the original, I would say this is an even function. Because when I negate x, it equals my original. Or you could say all the signs stay the same. You don't have to write this notation if you really don't want to, but you should give yourself an explanation. Same thing with the next one. I'm going to plug in -x wherever I see an x. Now this is 3 negatives. These 2 negatives cancel, leaving with 1 negative, so this ultimately becomes -x cubed, and a positive times a negative just becomes -3x. Now looking at this doesn't match the first one. Nope. and it doesn't match the second one either. So because they're both opposite, I'm going to say that this function is odd, because when I negate x, it's equal to the opposite of my original function. Or you could just say that all the signs are opposite of the original. For the last one, I'm going to do the same thing. Plug in negative x wherever I see an x. This negative, 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 again, just ultimately becomes negative minus 4. Now this one changed, but this one stayed the same. So because I have this mix of signs, it's neither even nor odd. Neither even nor odd. Because when I negated the x, it didn't equal the original, and it didn't equal the opposite of the original. And you can say that in words if you want, but that's the proper notation. So now what they want you to do on the bottom here is they want you to do this graphically. So all you have to do is graph all three of these guys, the same exact equations that are at the top in question 10, and analyze the graphs. The first one looks like this, and the second one looks like this, and the third one is like this. Now to do it graphically, all you have to do is analyze the symmetry. So the first graph is even, because I have symmetry. There is symmetry over the y-axis. Basically, this point is exactly like that point. It's a butterfly. The next function is odd, because there is symmetry over the origin. This point here is exactly like that point there, right over the origin. And the last graph has neither of those symmetry properties, so it's neither even nor odd. Because there's no symmetry. Your final question asks you to graph this function, f of x, on this interval. Now this is really important. They only give you that interval, so therefore you cannot graph outside that interval. So you don't want any arrows on your graph at the ends. So I'm going to make my table just for those values from -1 to 3. So -1, when I plug this into y equals, gives me the value of 7, 0 gives me the value of 0, 1 gives me the value of 3, 2 gives me the value of 4, and 3 gives me the value of -9. And all I'm going to do is plot these points. So -1, 7, 1, 2, 3, 4, 5, 6, 7 is up here, 0, 0, 1, 3, 1, 2, 3, 2, 4, 1, 2, 3, 4, 3, -9, 3, 1, 2, 3, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, when you connect these points, don't put any arrows. Now, looking at all these points, it's kind of hard to see the picture. So look at the window, look at the graph on your calculator to understand that it looks like this. Again, this is it. If I see arrows on your paper, you will get points off because they only want this interval. Do you see how it says equal to? That means a closed circle. Remember piecewise functions? It remembers a closed circle. No arrows. It's going to stop on that interval. The next question says, what's the degree? Well, let's analyze the function. If you look at the original, it's in standard form, and you should realize that the highest exponent here is 3. That is the degree. Do not add 3 plus 2. That's what you do for factored form. This is in standard form. You need the highest degree for standard form to get your degree, so it'd be 3. Then they ask, is the function even, odd, or neither? Well, looking at my graph, it displays no symmetry over the y, and it displays no symmetry over the origin. So I'm going to say neither, because no symmetry. Now, if you want, you could do it algebraically, like we did in the last problem. The original is this, -2x cubed plus 5x squared, and you could plug in -x if you want to do it algebraically. You should realize that this negative here stays negative, but it becomes -x cubed because it's an odd degree. and then a negative times a negative is a positive, so 2x cubed. This negative over here, the negative x squared, becomes a positive x squared because it's a negative times a negative is a positive. So a positive 5x squared. Now if you notice, this is the same as this, but this is not the same as that. So, because the signs are mixed, it is neither. Because only, you could say only one sign changed, or one sign stayed the same, or you can say the math notation, that when you negated x, it did not equal the original, and it did not equal the opposite of f of x. I hope that helps. Study up. There is a second review sheet on eBoard. The key is up there. I'm not doing a video for it, but you could use it as a reference and more practice. Good luck. This question asks you to algebraically find the x, y, and z values. Now, what I would tell you to do first is to use your calculator. Remember the second matrix, math, RREF, and then alpha zoom, pick 3 by 4. Do that first, and you'll get the answers of 0, 2, and -1. This is very valuable because this will get you 1 point, and 1 point is better than no points. And it also helps you because it tells you what the answers are, and if you made a mistake, at least you know if you're on the right track or off the right track. So remember, the first step is to always try to find two equations that cancel something out. And I see two, the first and the last have x that cancel out right away. So I'm going to put them on top of each other. Okay, and then these x's will cancel out, and I'll be left with 4y minus 4z equals 12. And I cloud it because I know I'm going to use it again. And then step 2, I want to cancel out the same letter. So remember, you want to cancel out the same letter in step 2. If you do not do that, you're going to be very confused. So I want to cancel out x. And I'm going to pick the last two equations because x is already negative here. So that kind of helps me cancel things out. So I'm going to write 2x plus 4y plus 6z equals 2. Then negative x plus 3y minus 5z equals 11. And what I want to do is I want to cancel out the x's. So what I'm going to do is I'm going to multiply the second one by 2. Remember, you might have to multiply equations in order to cancel things out. So I'll keep the first equation the same, and then I'm going to distribute this 2 to every single piece. So it'll become negative 2x plus 6y minus 10z equals 22. These guys will now cancel out. You'll end up with 10y minus 4z equals 24. And then we're going to cloud that guy. And the reason why I cloud these is because in step 3 I'm going to use both of them. So I'm going to put them on top of each other. And 10y minus 4z. Now, what's great about this one is that the z's are almost ready to cancel. You just got to multiply the second one by a negative. So what that'll do is I'll change all these signs, and I can cancel out the z's now. I'll get negative 6y equals negative 12. Divide by negative 6, and what is great here, y equals 2. And I'm going to go check what I got from my calculator, and that is 2, because remember, this represents x, y, and z. So I did the first step right. Well, first 3 steps right. So now, what I'm going to do is I'm going to take one of my clouds, and I'm going to plug in y equals 2. I'll pick the first one. Why not? So step 4. So I'm going to plug in 4 times 2 minus 4z equals 12. I'll get 8 minus 4z equals 12. Subtract the 8. I'll get negative 4z equals 4. Divide by negative 4. And then z gets you negative 1. And then again, I'm going to check if I have that for z. And yes, I do. So that is great. So I have z and y. And now to find x, I'm going to use one of the originals. The easiest one I see to use is the first one. So x I don't know, but I know y is 2. I know z is negative 1 and equal to 1. Now, fun fact. If you cannot find x and, well, y and z, like the first 2 letters we found, what you could do is kind of like cheat a little bit, because if you have all 3 answers from the calculator, you can just pick one of the equations, one of the original equations, and plug 2 of them in to at least show that you can find one of them. Hopefully that makes sense. So then you can get 2 points, which is great, and x equals 0. Boom. Okay, so last question says evaluate f of 3. All they want you to do is plug in 3 for x. So I do that. And minus 24. So you're going to plug this all into your calculator. Please use your parentheses, and you will get 0. And because you get 0, this tells me that x minus 3 is a factor because f of 3, equals 0. Okay, now to algebraically find our remaining zeros, you would try to set the thing equal to 0, and then you would try to factor. It is impossible to factor this thing, so what we're going to do is we are going to use synthetic division. So I'm going to put 3 inside the house and take all my coefficients. Drop down the 1. 3 times 3 is 3. 0, 0, 6, 18, 0, 0, 8, and 24, which gets you 0, which is what should happen. Then you're going to have x to the 4th, because that's 1 power down, plus, well, this is x to the 4th, x to the 3rd, x squared, x, plus 6x squared, plus 8 equals 0. And then you're going to get x squared plus 8 and x squared plus 4. Hold on, this doesn't make sense because we want to do AM here. So AM, the factors of 8 that add to 6 are 4 and 2. That's better. Set these both equal to 0. You get negative 4 equals x squared. So square root this, you get 2 answers plus and minus 2i. Great. And then subtract the 2, and you get x squared equals negative 2, square root, and you get x equals plus or minus I, radical 2. The I came out, but the radical 2 stayed in. So those are your remaining zeros using synthetic division. All right, good luck. See you guys soon.